Hi friends, welcome to my channel. Let's have a look at problem 1905, count sub-islands. So in this video, we're going to follow our line of traversal algorithms to present a solution based on breadth-first search here, and we shall present a iterative format. So this problem asks us to return the number of islands in grid 2 that are considered sub-island. So this problem also explains what does it mean by a sub-island. So an island in grid 2 is considered a sub-island if there is an island in grid 1 that contains all the cells that make up this island in grid 2. So with that said, let's have a look at an example. So let's look at example 1. So in example 1, so there are 5 islands in grid 2. So this is 1, and this yellow one here is 1. The two red ones are corresponding to 2 islands, and this 3 orange land cells form another island. So in total is there are 5 islands in grid 2, and 3 of them are sub-islands. So this red one, and also here the 2 red one here. So the output is 3. Let's also have a look at the constraints. So the first 2 items are basically consistency assumption, or it assumes that the 2 grids are the same in size. So both the number of rows and columns are bounded in between 1 and 500. And the grid value in grid 1 and grid 2 are either 0 or 1, corresponding to sea and land respectively. So with that said, let's look at the method and idea. So the method is a standard traversal algorithm in the large, in big picture. So the idea here is how to check so an island in grid 2 is a sub-island. So the idea is the following. Actually, it directly comes from the definition. So for an island I in grid 2 to be a sub-island of island in the sub-island in grid 1, if and only if any land cell RC in I for this position, so the corresponding cell value in grid 1 must also be land. So if one of the position violates this condition, then the corresponding island I will not be a sub-island. So with that said, this procedure actually is very straightforward. So first we'll write a breadth-first solution with an extra flag check. So when we are locating the number of islands in grid 2. So here is a notice or remark. So this is exactly the same as we did in Leetcode 1020 or 1254 video explanations. So here I would like to introduce a technical treatment. So when we visited a land cell in grid 1, in grid 2, so we are going to reset its cell value to be 0. So this way, we do not need to use a set abstract data structure to monitor the traversal. So that's what we want to do. So breadth first with flag check, and there's also a technical treatment in between. So here the plan is that I will write a format without writing a hyperfunction. So this is just a choice of a representational format. So we have different formats for this similar class of problems in the playlist. So it's good to have a look at them. So with that said, first let's do the preparation. So here I'm going to track the number of rows, number of columns, and initialize a queue and a count variable. So I'm going to do n rows, n columns, and queue, so and count. So basically it's length grid length grid 0. So these two variables corresponding to the number of rows and number of columns in grid 1 or 2. So let's use grid 1. So the queue I'm going to let's import a deck to place a row of a queue. So import deck. So I'm going to initialize a deck, and then the initialization for the count will be 0. So the count will be the variable whose final state is what we want to return. So with that said, we made the preparation. So next, so we are going to find the islands in grid 2. So also we want to locate those islands that are sub-island. So for this, I'm going to do iterations. So for row in range in rows, and for column in range columns. So this is standard. So when we match a length cell in grid 2, so we are going to do the traversal. So if grid 2 row column is 1, then we're going to do the traversal. We want to check also the corresponding island containing this position row and column if it's a sub-island. So for this, first let's introduce a flag. So it's initially it's true, and then we're going to introduce another variable called current island. So we are going to use a set to represent this island, and then so we're going to append the queue with the current position. So that's row column. So as we mentioned, so when we visited a position, we're going to set its cell value to be 0, right? So we're going to set grid 2 row column equals 0. So next we're going to do the standard iteration. So that's a while loop. So while queue. First I'm going to get the position. So it's queue pop left. So here the left is the head of the queue. So then we're going to check first if the corresponding cell position in grid 1 is land. If it's a land, so the current state of the flag is still true. If it's not a land, then we change the state of the flag to be false. So if grid 1, so RC is 0, so then the flag will be false. So that's a check, an extra check for, if we compare with the standard traversal. So next, we're going to add the current position to the current island. So next is standard. So we're going to look at the 4 neighbors of this position. So here let's write in a different format. So let's check if R is less than n rows minus 1, and grid 2, say R plus 1 C is 1. So this condition basically says that I want to look at R plus 1 and C position. So we want to make sure R plus 1 and C are inbound, right? So if it's inbound, so we're going to append the queue with the current position, R plus 1 C. Meanwhile, this position is going to be visited, so we reset its value to be 0. So grid 2, so R plus 1 and C equals 0. So next we are going to do the same thing actually for the other 3 neighbors. So we are going to check if column is less than n columns minus 1 and grade 2 are C plus 1. So if this is 1, so we're going to include this position. This R C plus 1. And then we're going to change the value of the corresponding cell. It's R C plus 1, 2 in grade 2 to be 0. So we checked R plus 1, R C plus 1. Then we're going to check R minus 1. Let's see. If R is greater than 0 and grade 2, so R minus 1 C is 1. So in this case, we're going to include this position, R minus 1 C. We are also going to do the reset, R minus 1 C equals 0. So next, we are going to check R C minus 1, right? We want to make sure C minus 1 is in bound. So if C is greater than 0 and grade 2 R C minus 1 is 1. So in this case, we are going to include this R C minus 1 and then reset the corresponding position to be 0. So that's the main logic. So after this while loop, actually it's corresponding to a BFS search. So then we are going to check again the status of the flag. So if flag, then we're going to increment the count by 1. So that's actually it for this whole solution. So the remaining part is the return. So we're going to return the count state. So that's actually this part actually plays the role of a breadth first search helper function. So but we put this inside a double for loop. So we finish all these things in one big iterative for loop. So with that said, let's have a look at the test cases. First, do a special case check. Columns is not defined, so for n columns, yeah, it passes a special case. Now let's look at the generic cases. Yeah, it passes the generic cases. So let's check again. So let's see, it should be fast. So anyway, so that's a format of solution. So in this solution, actually we did the things in one go. So there are actually different formats of solutions for this kind of problem. So all the formats actually are good to be aware of, and you are also encouraged to try. So to write different formats and using different check method. So with that said, I guess that's about it for this video. Thank you very much.